You know how your phone just magically finishes your sentences? Or how a search engine digs up the exact answer you're looking for, not just a bunch of links? Well, today we're pulling back the curtain on how we teach machines our most human skill, language. We're going to see how it all really works. But, okay, before we get into the nuts and bolts, we have to start with a really big, almost philosophical question. What does it actually mean for a computer to understand language? I mean, a toddler understands language, right? But does a dictionary? It has all the words, but it can't put them together to tell a story. And that's the core puzzle we're trying to solve. So to get to the bottom of this, we're going to go on a little journey. First, we'll look at the language puzzle itself. Then we'll see how we first tried to crack the code. After that, we'll dive into the big breakthrough, the attention revolution that powers all the AI used today. And finally, we'll look at where all of this is heading. All right, first up, the language puzzle. Why is something so natural for us, like just talking, a total nightmare for a machine that thinks in ones and zeros? Well, the short answer is that human language is beautifully, and for a computer, frustratingly messy. Just think about it for a second. Our language wasn't designed in some lab with a clear set of instructions. It grew, it evolved over thousands of years. It's this living, breathing system, packed with ambiguity, unspoken rules, and a massive reliance on shared context. Its real power for us is its flexibility. But for a computer, that flexibility just looks like pure chaos. And this is really the heart of the problem. A computer's native language, like Python or Java, is the exact opposite of ours. Every command has one and only one meaning. The rules are totally rigid. But in our world, the word bank could be where you put your money or the side of a river. And new words like yeet just pop into existence and suddenly everyone knows what they mean. This is the massive gap we needed to bridge. So how in the world did we even start to bridge that gap? Well, the first big idea was kind of brilliant. The pioneers decided, you know what, let's stop trying to teach computers grammar. Instead, let's just turn words into the one thing computers are amazing at, numbers. This led to a really clever, simple technique called bag of words. The idea is exactly what it sounds like. You treat a sentence like a literal bag full of words. You dump them all out, ignore the grammar, forget about the order, and you just count how many times each word shows up. That's it. So, a simple sentence like, "The cat sat on the mat," gets turned into this simple list of numbers, what we call a vector. Just like that, a sentence, this messy human thing, is now something a computer can actually process with math. This was a huge first step. But here's the fatal flaw. Because we threw out the word order, the cat sat on the mat and the mat sat on the cat, two sentences with completely different meanings look identical to the machine. So yeah, we turned words into numbers, but in the process, we lost the single most important thing in language, context. And that failure, that total inability to grasp context, brings us to the modern era of AI. It brings us to the breakthrough that finally solved this problem. This is what we call the attention revolution. And this is the innovation that finally taught machines how to understand the relationships between words. And believe me, it was a revolution. Once this key idea was introduced in 2017, things just exploded. The size and power of these language models went vertical. We went from millions of parameters to hundreds of billions of parameters in just a handful of years. This right here is the engine behind the AI boom that we're all living through today. And that engine is a deep learning architecture called the transformer. Its secret weapon, its superpower, is a mechanism called self-attention. What it does is, instead of just reading words one by one, it looks at the entire sense all at once, and for each individual word, it figures out which other words in the sense are the most important for understanding its meaning. Let's look at an example. Take a tricky little word like it. In this sentence, to understand what it refers to, a machine can't just look at the word itself. It has to understand the full context, all the other words dancing around it. And that's exactly what the self-attention mechanism does. It scans the whole sentence, creating these connections and weighing the importance of every word to every other word. It learns that it is strongly linked to planet. It grasps the sentence's internal logic. For the first time ever, the machine isn't just seeing words, it's seeing context. So, great, we've cracked the context puzzle, but what's the payoff for you and me? Well, this technology isn't just stuck in a research lab. Let's talk about where it's already showing up in your day-to-day life. Honestly, it is everywhere. Every single time you type something into a search engine, get a translation, see a little grammar suggestion pop up, or ask a virtual assistant a question, you are using an incredibly powerful natural language processing model that is built on these exact principles. Let's just take search engines. When you ask a question now, modern systems work in two steps. First, a component called the retriever zips through billions of web pages to find just a handful of relevant passages. Then, a super powerful reader model, using that same attention mechanism, deeply analyzes just those few passages to pull out the precise answer to your question. It's this amazing combo of incredible speed and deep, focused understanding. Okay, so this brings us right to the edge, to the frontier of what's next. Now that machines have this powerful grasp on language, the next great challenge is all about making them more reliable, more accurate, and, actually trustworthy. Because these models learn from just massive amounts of text scraped from the internet, they come with some serious technical hurdles. They can sometimes state things that are completely false with total confidence. That's a phenomenon people call hallucination. They can also accidentally memorize and spit out sensitive data they saw during training. And, of course, the quality of their output is completely at the mercy of the quality of the data they learned from. And this really points to a fundamental challenge in how these things learn. They are trained on a snapshot of the internet, so they absorb everything in that data, the good, the bad, and the ugly. The core technical problem for the next generation of AI is figuring out how to make these systems more discerning. How do we teach them to identify and prioritize what's factual and high quality? And that all leads us to the biggest question on the horizon. We've managed to crack the code on context and conversation, but the next great challenge is all about reliability and reasoning. As these models become more and more a part of our world, the ultimate question isn't just about understanding language anymore. It's about ensuring that understanding is accurate, verifiable, and genuinely helpful. So, as AI masters our most human skill, how do we make sure it reflects our best values?